morning, class. I am Miss Jessa Dibaring, your instructor in Physics 105 lecture. Do you have any idea what is our topic for today? Anyone from the class? Yes, very good. Our topic for today is all about the branches of thermodynamics. Before we proceed, we should first determine our learning objectives. Our learning objectives are define thermodynamics. What are the four branches of thermodynamics? Distinguish the relationship between heat, work, and energy. If we say branches of thermodynamics, it is the study of thermodynamical system, hence developed into several related branches, each using a different fundamental model as a theoretical or experimental basis, or applying the principles to varying types of systems. Next is, what is thermodynamics? Is a branch of physics that deals with heat, work, and temperature and the relation to energy, radiation, and physical properties of matter. If we say thermodynamics, it is the study of heat and its transformation to mechanical energy, which stems from Greek words meaning movement of heat. Another meaning of thermodynamics is thermodynamics applies to a wide variety of topics in science and engineering, especially physical chemistry, chemical engineering, and mechanical engineering, but also in other complex fields such as meteorology. Next is, what are the four branches of thermodynamics? Yes? Anyone? Okay. The four branches of thermodynamics are classical thermodynamics, statical thermodynamics, chemical thermodynamics, and equilibrium thermodynamics. If we say classical thermodynamics is the description of the states of thermodynamic systems at near equilibrium that uses macroscopic measurable properties. So classical thermodynamics, it is used to model exchange of energy and work and heat based on the laws of thermodynamics. Next is statistical thermodynamics. Emerged with the development of atomic and molecular theories in the late 19th century and early 20th century, and supplemented classical thermodynamics with an interpretation of the microscopic interactions between individual particles or quantum mechanical states. Statical thermodynamics, it is a natural result of statistics, classical mechanics, and quantum theory at the microscopic level. Next is chemical thermodynamics. Chemical thermodynamics is the study of the interrelation of energy with chemical reactions or with physical change of state within the confines of the law of thermodynamics. Chemical thermodynamics, it is the study of how heat adhere both in changes of state and in chemical reactions. Next is equilibrium thermodynamics. It's the study of transfers of matter and energy in systems or bodies that by agencies in their surroundings can be driven from one state of thermodynamic equilibrium to one another. equilibrium state that are two unbalanced potentials or driving forces between microscopically distinct parts of the system. We say next is non-equilibrium thermodynamics is under of equilibrium thermodynamics. While the non-equilibrium thermodynamics is a branch of thermodynamics that deals with systems that are not in thermodynamic equilibrium. So, meaning, it is the study of non-equilibrium system requires more general concepts than are dealt with by equilibrium thermodynamics. Last is distinguish the relationship between heat, work, and energy. The relationships between heat, work, and energy is that heat is the energy associated with the random motion of particles, while the work is the energy of ordered motion in one direction. Therefore, heat is low quality energy and work is highly quality energy, and this support the entropy statement of the second law. Before we end our discussion, I prepared 5 trivia questions about thermodynamics. So, are you ready, class, to listen? Okay, very good. First trivia. At a standard temperature and pressure, what is the heat of formation of water vapor? The answer is negative 241.82 kg. Next trivia. Thermodynamics is a wide branch of disciplines. Which branch of thermodynamics studies the changes of enthalpy of a reaction? What is the answer? The answer is thermochemistry. Third trivia. At what rate do all objects accelerate to Earth, assuming no air resistance? The answer is 9.8 m/s per s. Fourth trivia. Not including the zeroth law, how many laws of thermodynamics exist? How many? Okay, 3. Last trivia. Even if they were not strapped in, why would not astronauts hit their heads on the ceiling of the shuttle as it falls? The answer is both they and the shuttle are in free fall. Okay, so that's all the trivia. Okay, for the activity, prepare yourself, class. In this activity, students should work with pairs. Okay, this activity will be by pair only. So each pair should start by discussing the first law of thermodynamics and attempting to restate it in their own words. You need to do is to create a comic strip that fully explains the first law of thermodynamics, like how and why it works, why is it important, and how it matters in the context of chemistry. So class, I give you 15 minutes to enjoy your work. Don't be pressure, class, just enjoy. After you finish your work, class, you may present here in front to discuss your work or share your ideas about your works. So, class, for your assignment, for the next meeting, I would like you to differentiate differentiate the four branches of thermodynamics: the classical thermodynamics, statistical thermodynamics, chemical thermodynamics, and equilibrium thermodynamics. Then, um, that's all for our discussions for today. I hope you enjoy and learn about the topics. If you have any violent reactions, suggestions, or comments about our topic, please don't hesitate to approach me. Remember, class, I am an approachable teacher. So, that's all, class. See you on next meeting. God bless and goodbye.